Welcome to Train Signal. You're watching a lesson on the OSI model. In this lesson, there are two main things that we're going to talk about. Number one, we need to learn what a protocol is, and then that is going to allow us to learn about the OSI model. So let's go ahead and get started. So the first step in learning about the OSI model is to first understand the term protocol. Now on the screen I have a definition of this term for you. A protocol is a set of rules and procedures used for communication. But what exactly does that mean? What does it mean, rules and procedures for communication? Well, I want to try to explain this to you by using a couple of examples of other types of networks where we need to use certain protocols. So the first example I want to give you is the United States Postal Service protocol. So what I want to do is I want you to think of what would you do if you wanted to send a letter to a friend. Okay, you have this letter, you've written it up, you want to mail it to a friend, and you want to do it using the United States Postal Service. Well, the first thing you're going to have to do is you're going to have to put it in an envelope. The next thing you need to do is you need to put a destination address on that envelope. Okay, and I have to tell you at this point, this is where this is truly a perfect analogy. The United States Postal Service protocol could actually be considered to be a protocol suite. And that's the same thing with computer networking. The protocols that we commonly talk about, things like TCP/IP, those are actually protocol suites. And we will learn more about that not only as we go through the OSI model here, but as we go through additional lessons on the different protocols, and to be specific, on the TCP/IP protocol. Now, the reason that we call it a protocol suite is because it's actually a set of smaller protocols all working together to make this big United States Postal Service protocol. So when I say you have to put an address on the envelope, and to be specific, this would be the destination address, right? Well, that address needs to follow certain rules and procedures in itself, right? We have to format it in a certain way where we put the name, right? First name, last name, and then we have the street address where you have the street number and the street name, suffix, city, state, zip code. I'm not going to go into all the details of the United States Postal Service, but the address has to be done in a certain way, and it has to be put on a certain location on the envelope. Once we are done with the destination address, well, we then have to put a return address. Or in computer networking, this would be considered to be the source address, meaning we're going to put our own address so that if there's a problem in communication and it can't be delivered to that destination, it can be sent back, or at least attempted to be sent back to the originator. And again, just like I was mentioning with the destination address, the return address or the source address has to have its own set of rules and procedures that are followed as far as how it's formatted. So now we've taken the letter, we've put it in an envelope, we've put a destination address, we've put a source address. Now we have to pay for it, right? That's one of the rules, is you have to pay the United States Postal Service if you want them to take this letter for you. And you do that by attaching a stamp in an appropriate location on the envelope, right? So now we have our letter, it's in the envelope, it's all addressed, it's all paid for, stamped, good to go. What else do we need? Well, really there's one last step. We need to have a way of getting that letter out onto the United States Postal Service network, right? We have to get it into their hands so that they can then have it travel their network and get it to your friend. So what we do is we go out, and really there's a number of different ways we could do it. What I have here is an example of a mailbox where we go ahead and just take the letter, stick it in the mailbox. You could also give it to a postal carrier. You could go to the post office. Many different ways. But one way or another, you have to get it out onto the United States Postal Service network. Now, like I said before, all of these individual steps are kind of like individual protocols on their own. Okay, it's a bunch of small, different sets of rules and procedures. You put them all together and you get one big set called the United States Postal Service protocol. And if you follow these rules and procedures as have been set by the United States Postal Service, then your letter should get to your friend. How about another example? Let's say instead of sending that letter via the United States Postal Service, you want to send it with FedEx. Well, then guess what? You're going to have to follow the FedEx protocol. And I'm not going to go through all the different steps, but I'm just kind of showing you here that, well, again, you have to put it into an envelope, but it's not the same type of envelope. There's a much bigger, different shaped size FedEx envelope that you'd put it in. Again, you have to put the source address. You have to put a destination address. But again, it's different places, and the formatting is different, and the information needed is different, right? There's phone numbers included now and things like that. You still have to pay for it, which is not done with stamps. It's done by either paying cash at a FedEx station, or you can use a FedEx account that you may have, but you still have to have that payment. And then you have to have a way of getting it out onto the FedEx network. And so, again, there are FedEx mailboxes, or you go to a FedEx station, and so on and so forth. The idea here is just understanding that there are many different protocols out there, right? We have the United States Postal Service protocol. We have the FedEx protocol. Some of the others that come to mind is I could have sent it with UPS or DHL, and I'm sure there are many other carriers out there, and each one has their own set of protocols. But here's the thing. If we're going to have appropriate network communication, then both the sender and the receiver, okay, so we'll just say both computers, if they want to talk to each other on a network, they have to agree upon a certain protocol. They have to agree upon the same set of rules and procedures used for communication. Because what would happen if you tried sending this letter via FedEx, but the destination was a United States Postal Service P.O. box or post office box? You can't do it, okay? And the reason you can't do it is because there are certain rules involved with the FedEx protocol. And by the way, one of those rules is that there has to be a signature of receipt. And you can't get that signature when you're delivering to a post office box. Okay, so at this point, we should understand what exactly a protocol is, what we mean by a set of rules and procedures for communication, and understand that both sides, both the sender and the recipient, must agree on a common protocol. All right, so now that we have thoroughly gone through and made sure we understand the definition of a protocol, I want to make sure to review one of the really important components here, which is the idea of standards of communication. Because in the examples that we used, it didn't matter what carrier we were involved with, whether it was the United States Postal Service, FedEx, or any of the other carriers you want to choose. One way or another, you had to have some form of packaging, right? The rules may be different, but you had to have packaging. Likewise, you also had to have addressing, right? You can't just hand the letter to the postal carrier and say, bring it to my friend, and they just figure it out on their own. No, you have to have some form of addressing. And then again, all the carriers, well, they're in this to make money, right? So you have to pay them for the service. And you also had to have a way of getting it from me over to the carrier and get it out onto their network. And so just, again, just to be really, really clear here, the rules, the individual rules with each carrier may differ. But all four items that you see in front of you right now, okay, the packaging, addressing, payment, and getting it out on the network, those have to be satisfied in some capacity in order for this all to work. And that's called standards of communication. And what I'm going to tell you is, you know, if you're thinking to yourself, hey, you know, we've spent an awful lot of time talking about protocols when this is supposed to be about the OSI model, well, now we can go over and see how this all relates. So this is where we can now jump in and truly learn about the OSI model. And before we even get started, I will tell you that there are a lot of different ways of presenting the OSI model. This is a very high-end, extremely complicated thing. Every single book I've ever read on the OSI model has had a different explanation. Every class I've ever gone to has had a different explanation. There's a lot of interpretation that's out there, and there's a lot of gray area. So going into this, I want to tell you that what I'm going to do is I'm going to take you through this piece by piece and let you know that I'm just giving you the real basic pieces that you need to understand to be able to be successful as a network administrator. I don't expect that when you're done with this lesson that you are going to be the foremost expert on the OSI model. I don't even consider myself to be the foremost expert on the OSI model. There are very few people out there who do consider themselves to be absolute experts on the OSI model. So let's jump into this. The first of these steps is to just kind of quickly take us back in time so that you can understand where it came from. Back in the late 1970s, there is a group called the International Organization for Standardization, or what's known as the ISO. And yes, I know that looks a little bit confusing and maybe backwards, right? Because it's International Organization for Standardization, which is not ISO. And you may even see it referred to, because I know I've seen it referred to in different places as the International Standards Organization, right? Because that's what the letters sure seem to stand for. I don't want you to worry about that. I just want to make sure to clarify in case that confuses you. I know it has confused me in the past when I first learned about it. But this organization, it's a bunch of geeks who get together and say we need to make things standardized in order for them to work. Okay, that's kind of what they do. So what they did was they developed the OSI, which appropriately does stand for Open Systems Interconnection. And the reason that they developed this model was to define the basic standards for network communication. And I will tell you that this is not something where like this group of geeks just got together in a room and ordered some drinks and some lunch and walked away and said, bingo, we've got it. No, I can tell you that this took a number of years, and in fact, it actually wasn't until 1984 that the OSI model was officially released. But when we want to talk about the basic standards for network communication, what we're talking about is, well, what I just mentioned a few moments ago when I talked to you about how, didn't matter what protocol we were using, we still had to have packaging, we still had to have addressing, we still had to have payment, and we still had to have a way of getting it out on the network. Those are standards. Okay? The specific individual rules are set by the individual carriers. But you have these underlying rules that have to be followed. So that's the first step to understanding the OSI model, is just knowing its purpose. Its purpose is to set those standards. Now, the next thing you need to know about the OSI model is that it is a 7-layer model. Okay? There are literally 7 layers that you have to learn. You have to memorize. You have to know. Okay? You have to know the names of these layers. That's the first step. And I have them listed here. You have application, presentation, session, transport, network, data link, and physical. The question is, how the heck do we memorize those 7 layers? Oh, and by the way, you don't just have to know the 7 layers. You have to know them in order. You have to know the application is on top and that physical is at the bottom. So how are we going to do this? What we need to do is start off with just the first letters, okay, A, P, S, T, N, D, P, and then put some kind of a catchy saying that goes along with it so that we can remember those letters. And the most common one, and one of the original sayings that was out there, was that all people seem to need data processing. And yeah, we're actually using the term data processing, which means you can tell we're going back a good number of years. Okay, so if you can remember the saying, all people seem to need data processing, from that, you can look at those first letters and say, all right, I can remember A, P, S, T, N, D, P. And with just a little bit of studying, you can then remember what those letters tie to as far as application, presentation, session, transport, network, data link, and physical. The problem is that all people seem to need data processing may not be easy for you to remember. So I'm going to give you another one. And this time we're going to do the saying from the bottom up, which is, please do not throw sausage pizza away. Many people like this saying instead because it has nothing to do with technology at all. It's just simply talking about pizza. And so I guess that's maybe easier to remember. And I will tell you that if you go out on the internet, you'll find all kinds of additional sayings. Here's a few that I've thrown out there that I find. A priest saw 2 nuns doing push-ups. All people should try new Diet Pepsi. Please do not take salespeople's advice. And please do not tease stupid party animals. Again, the ones where we're going from the bottom up with the please do not, just be careful not to turn that into please don't. Otherwise, I personally think these are some pretty funny sayings. And if any of these you happen to find catchy, well, then use it. And I don't even honestly care if you come up with your own saying. But whatever it is, you're going to have to remember what the 7 layers are by name. Now on to the part that takes just a little bit more effort. Okay, it's easy for most people to comprehend the idea of what the OSI model was created for, And with just a little bit of work, you can remember the 7 layers and even remember the order. But from there, we now have to move into how does this actually work? And I will tell you that this is where a lot of the gray area comes into play. Okay, there's a lot of interpretation that goes along with this. And unless you reach super geek status and you want to go ahead and read the actual white papers directly from the ISO, well, you're not going to know absolute literals. And that's okay, because the only people who really have to know those absolute literals are the people who are developing protocols and developing networking devices to work within those protocols and things like that. As a network administrator, even on a senior level, you really don't need to know much more than what I'm going to give you right here. As a matter of fact, what you're looking at right now is what I commonly refer to as my one-page cheat sheet. Where do I classify that? Like, why is this everything you need to know? Well, I taught to enough people who were just trying to pass networking exams that I was able to say this is anything and everything you need to know for the exam. But I can take it a step further and say this is probably pretty much everything you would need to know even to be successful as a network administrator. So let's take this one-page cheat sheet and break it down. Okay, so we're going to kind of hide some of that, and let's just start with a simple OSI model and have an understanding of what each layer does. Okay, what's the purpose behind each layer? What is it responsible for? And again, if you open up a book, you're going to go through and see a paragraph on each one of these 7 layers. And I personally find that very difficult because, well, paragraphs are much harder to learn, and there's also interpretation. So I'm going to break this right down into single 1 or 2 word definitions. And then if I just have a basic understanding of what I mean by that definition, well, then we're good to go. The top layer, the application layer, is responsible for something I call network APIs, which is network application programming interfaces. Meaning it's just pretty much what it sounds like. It's the application interface. It's the computer or the program on the computer saying, hey, I've got something for the network. Okay, so it's just an interface between the network and the application on the computer. Moving down a layer, we have the presentation layer, which is where we format the data that's going to be put out on the network. Okay, as far as if it's going to be, some kind of ASCII or ABCDIC or who knows what kind of formatting we want to have this data be in. But that's done at the presentation layer. The session layer is involved with synchronization, and in the case of some protocols, there is timing involved. And so the session layer can help with the synchronization or the timing of communication. And matter of fact, I'll pause for a moment in going down the list right there and say, just so you know, this is something that was developed many years ago, and all components of the OSI model are not always necessarily used, or at least not used in their most literal sense, by today's protocol standards. You'll learn more about that as we learn about individual protocols, and to be specific, the TCP/IP protocol. But getting back to this, let's move down to the transport layer, and I just have the word packets written there, or sometimes I'll put down packet management. When data is sent out on the network, it is broken down into individual packets. The management of those packets takes place at the transport layer. The network layer is responsible for the addressing or routing of the packets, so it has to do with getting the packets addressed, like we talked about even in the postal carrier example, and then also deals with how those packets will be routed, or let's move away from that term packets, because I don't want to confuse it with the transport layer. We'll just say the data, how it gets routed to its destination. The data link layer, although I'm not going to go into detail here, I will tell you that it was further broken down into 2 sub-layers, and I will tell you that what their names are. It's LLC, which is Logical Link Control, and MAC for Media Access Control. We're not going to worry about that for right now. What I want you to know is that the data link layer is responsible for data frames or data frame management. And I can tell you that if you were to go out and look up packets and data frames, you would see those terms are sometimes interchanged. Some people will say, oh yeah, well there's data going out on the network and it's broken into packets. And then other places will say there's data going out on the network and it's broken down into frames. So how is it that the transport layer deals with packets and data link with data frames? Well, what we mean here by data frames is although they are sometimes referred to as the same thing as packets, it's more of the packaging of those packets. And the best analogy I could use is think of it as like putting the letter into the envelope. Okay, you're putting it into the appropriate envelope based upon the protocol that you're using. That's what data frame is. And the last layer, going from top to bottom, is the physical layer. And that layer I just have written hardware. That layer just has to do with how does the data actually get out onto the network, or how is the cable attached to the network card, or we could be talking wireless. Okay, so how are we actually connected out onto the network? Now, again, I want to emphasize, don't take my definitions 100% literally, because they're not meant to be. They're meant to be very vague and very general, because again, remember, a lot of gray area. But that's the basic idea behind these 7 layers. Now, the next piece that we need to throw back into this model is a piece that explains how exactly data travels through the OSI model and how communication takes place. What I've done in this one-page cheat sheet is I have added a second OSI model, and the reason I've added a second one is because I've also added a representation for the 2 computers that are communicating, right? I have a sending computer and a receiving computer, and they are up at the top of the OSI model, and that is intentional. What I've also added is I've added a network cable to the bottom of the OSI model, attaching them together. None of this stuff is by accident. It's all exactly where it should be. Now, the rest of what I've added to this one-page cheat sheet is, you'll notice there are some arrows in between the layers, and there are some dotted lines going across between the 2 OSI models. What this all represents is how data travels through the OSI model. When the sending computer has some data to put out there, it passes it down to the application layer of the OSI model, which then gets passed down to the presentation layer, passed down to the session layer, and continued passed all the way down through the OSI model till it gets to the physical layer. What happens at each of those layers when it's being passed down is each one of those layers adds its own piece of formatting, so to speak, or its own piece of significant information to the data itself. And this information that's being added is very often referred to as adding header information. There is a header added onto the packet of information, okay, onto the data that's going out there. And I will add to that the data link layer actually adds a trailer as well as a header. Now, right now, if you're feeling a little confused because I'm talking but I'm not really showing you, don't worry, I'm going to illustrate this for you in just a moment. But for right now, just understand that you start off with data. It goes down through the OSI model with information being added at each layer until it gets to the bottom. And at the physical layer, it says, great, I've got this piece of data. It's all formatted and it's ready to go. Let's put it out onto the network. It goes out onto the network cable, and it goes across to the receiving computer. And at the receiving computer, the physical layer grabs the data, and it sends it up through the OSI model, through each of the layers. And at each of those layers, it acknowledges and strips off the piece of information, again, that header or trailer information, that was added by the corresponding layer on the sending computer. And so by the time you get all the way back up to the top, when you get to the application layer, the receiving computer just has the raw data that, the sending computer originally sent. Now, that's why I have the dotted lines. The dotted lines represent that you have virtual communication taking place straight across within the same layer. Okay? In other words, the application layer, although it passes the information down to the presentation layer and then down to the session layer and all the way down to the cable, and then it comes back up until it gets back up to the application layer. That's how the data moves, but the communication is from the application layer on one computer directly with the application layer on the other computer. Now again, remember, there's a lot of gray area to this, and there's no literals to these 7 layers. And that's what's so hard for people to grasp onto very often when it comes to the OSI model. There's nothing I can physically show you. I can't pull out a network card in a computer and show you 7 chips, one representing each layer. No, they don't exist. These are all theoreticals. And so because there are no tangibles, I want you to grab each one of these things that I'm telling you one piece at a time. Now, I promised you an animation, so let's look at that now. We start off with a computer that wants to send some data. So I have some raw data here. What that computer does is it sends it down through the OSI model. And as you can see here, the layers are each adding their own piece of information. And again, when it got to the data link layer, notice that besides the header information on the right side of the data, there was also that one little piece of trailer information on the left side. And to be more specific, I will tell you that that trailer information, it's error correction, and or I could maybe say error prevention. It's a way of very quickly, when you get to the other end and the data link layer is looking at that, if it doesn't see that error information, it knows that the data is corrupt and it throws it out, and then there has to be a retransmission. Okay, but as you can see here in the illustration, this data has made it all the way down through the OSI model, and now it's on the physical layer. Who's going to do what? That's right, going to send it over onto the network cable until it gets received by the other computer. And at this point, the physical layer grabs it and sends it up through the OSI model, stripping off the appropriate information corresponding with the layer on the sending computer who had added that information. And as you can see here, when it gets back all the way up to the top on the receiving end, it's just the raw data that the sending computer originally sent. Now, there is one comment that I will throw out there, and that is, there's one big mistake here in my illustration, and that is that the header, all this header information that was slapped onto the data, it actually looked bigger than the data itself. That's false. I can tell you that all that header information is actually a very, very small percentage of the overall transmission that's going to take place. I only did large slices so that you could see them here. So getting back to our one-page cheat sheet, we now have the OSI model, we have our definitions over to the right, we have our lines all being drawn with our computers at the top and the cable at the bottom. There's one last thing you need to know to fully understand, at least as much as I want you to understand right now when it comes to the OSI model. And that is over here on the left, we're going to talk about just a few. There are more than just these, but I'm going to go into a few examples of hardware, and to be more specific, we could say networking hardware or networking related hardware, and where it functions or at least relates to the OSI model. Starting from the bottom, you'll see that I have the words hub or repeater. These are two very basic pieces of networking hardware that have extremely limited functionality. Matter of fact, the functionality of a hub and a repeater is so limited, you don't even see them very often in today's networks. In both cases, whether it's a hub or a repeater, there's no brains involved, meaning a hub will grab hold of the data and its sole responsibility is to retransmit it out to all other connected devices. And it's not even dealing with the devices. It's literally just putting it back out on all the different cables that are plugged into it. And the same thing with the repeater, except for a hub is like a multi-port repeater. A repeater just takes in the information and repeats it back out again. And that's why it's down at the physical layer, because that's all it knows. It just knows how it's connected to the network. It knows how to transmit, and that's it. Whereas if we move up a layer to the data link layer, this is where a bridge, which again, we don't see bridges too much anymore in today's networks, but switches we do see. Switches function at the data link layer, and the reason is because there's a little bit of brains involved in a switch. What a switch will do is it will take the information and it will retransmit it out in the direction of the recipient computer using, and let's see if you can tie this all together here, using a routing table, not to be confused with routers, we'll get to that in a minute, but a very simplistic routing table based upon MAC addresses, which are the physical addresses of the individual network cards of the computers out on the network. Now, the reason I said let's see if we can tie this all together, I said it's called a MAC address, MAC standing for Media Access Control, which I mentioned earlier is one of the sublayers of the data link layer. Okay, so you can see how this all ties in. Now, real quick, before we move on to the next device here, I want to make one other brief mention. As long as we're talking about MAC addresses, I want to also point out, we're not going to go into detail on this right here, but there is also something called EUI-64, which is a specification related to MAC addresses. Okay, it's a specification of a type of MAC address. It tends to work typically in your IPv6 environments. The reason I'm bringing it up right here is because if we're going to talk about MAC addresses, which of course is the media access control sublayer of the data link layer, what that means is that anything EUI-64 related is also going to function at that same media access control sublayer of the data link layer of the OSI model. Moving up a layer, we have routers. This is an easy one. What did I say takes place at the network layer? Addressing or routing. So when you are in a network, or really, as we'll learn in another lesson when we talk in more detail about routing, when you're in a multi-network environment and you have to send something from one network to another, you need to go through a router, and that router is going to have functionality at the network layer. And then if we jump all the way up to the top, there's that device I mentioned a long time ago, way back at the beginning of this lesson, and that thing is called a gateway. And a gateway, what did I say it was? It's a protocol translator. And I will tell you that although I have listed it up at the top at the application layer, that is not literal. There are protocol gateways or translators that can have functionality really throughout the OSI model, depending on what type of protocol and what type of translation is taking place. But most of your protocol translators do tend to be high level or high layer based protocol translators. And that's why I put it all the way up at the top at the application layer. Now, before we wrap things up, I will mention that there is also the concern of where certain encryption devices function at the OSI model. And, similar to the gateway, there's really not one particular layer that all encryption devices function at the OSI model. You really have to take a look at what the device is and what's being encrypted to figure out what layer of the OSI model the functionality is really taking place at. And that's part of why, if you look at what I have here, you use this as a base, you can usually figure out whether it's an encryption device or some other type of device, where it actually functions in the OSI model. And so that brings us to the end of this lesson. And just to kind of quickly wrap this up, remember, we talked about protocols, and really the reason was so that we can understand the idea behind standards of communication, where you have to have certain standards. And although I used an example of the actual mail carriers, same holds true for network communications. And it's because of the need for those different standards that we had to come up with this thing called the OSI model. Now, when it comes to making sure that you fully grab hold of what I've been trying to tell you with the OSI model, I cannot emphasize enough how I just want you to take each individual thing that I've talked to you about and take it piece by piece for exactly the way I told it to you, okay? Just for exactly what it is. Because what many people tend to do is they really want to grab hold of this whole huge thing, and it's it's really this huge thing when it comes to the OSI model. I mean, it's massive, okay? So I want you to understand there's a lot of gray area, a lot of things that there's a lot of interpretation to, and just take things individual the way I gave them to you, and I promise you, you will do just fine. So with that, that brings us to the absolute end of this lesson, and I will see you in the next one.